The question number 16 says that in a photocell, the graph between the stopping potential and the frequency of the incident light is given as shown. The Planck's constant is equal to C. This is the graph in relation to Einstein equation. And what was the equation? That kinetic energy, which was equal to E into the stopping potential, is equal to E into h nu minus h into nu naught. This is the threshold frequency. Therefore, the stopping potential Vs is equal to h divided by E nu minus h divided by E into nu naught. This is the graph of straight line like this one. So if you compare, so y is equal to like mx minus c. And see, h upon E become the slope. And if you look at the graph, we can find the slope from the graph. If you know this value, okay, we know this value which is 5, and we know this value 2, and this value we can calculate. So I can take the slope, and the slope h upon E is equal to, the slope of this line becomes, that is equal to 5 minus 2 from here divided by this one, which is equal to 2 minus 1.2, and power is 10 to power 15. So this becomes 3 divided by 0.8 into 10 s power minus 15. So what is h equal to? E, which is equal to 1.6 10 s power minus 19 into 3 into 10 s power minus 15 divided by 0.8. So 0.8 cancel with this 2, and 2 into 3 6, 6 into 10 s power minus 34 is the value of h. So the correct option is 6 into 10 s power minus 34. Answer to this question is 3. Now the question number 17 says that electron in a hydrogen atom makes a transition from the first excited state to the ground state. The magnetic field at the center due to the motion of the electron will increase to, these are 4 options. Now dear students, at the center magnetic field on circular path is mu naught I divided by 2 pi r, and this is mu naught upon 2 pi r, and current is charge divided by the time, and the time is equal to 2 pi r and divided by velocity. So v is proportional to velocity divided by r square. It is jumping from n is equal to 2 to n is equal to 1. That is happening. Now v is proportional to z by n, and r is proportional to n square by z. If you fill from here, then v become equal to 1 by n and 1 by n power 4, so 1 upon n power 5. Now as it is making transition from 2 to 1, so therefore the new magnetic field become equal to 2 power 5 times the magnetic field of the initial value. So this become equal to 32 times the magnetic field of the initial value. So answer to this question is option number 4. Question number 18 is a monochromatic point source of light is placed at the focus of a convex lens. A photocell is placed at a distance of 0.2 meter from the lens. Then cutoff voltage and the saturation currents is 0.6 volt and 18 milliampere. If the same cell is placed at distance of 0.6 meter from the lens, then cutoff voltage and the saturation current. Now see, if the intensity changes, then there will be change in the saturation current. But you find that there is a convex lens, and at the focus of a convex lens there is a source. Therefore, after refraction through the lens, these rays will be the parallel, so it become a plane wavefront. And in case of plane wavefront, the intensity is independent of distance. Therefore, at whatever the distance you place the photocell, the intensity will remain unchanged. So the results will be unchanged. You will get the same data, 0.6 volt and 18 milliampere. So the answer to this question is the first option. Question number 19 says, when the speed of an electron beam used in Young's double-slit experiment is increased, then which among the following statement is correct? The interference pattern will not We observed in case of electron, distance between the consecutive fringes increases or distance between the consecutive fringes decreases or whole fringe pattern will shift. Now see what is happening this one, that electron beam is used, then d by wavelength is equal to h upon mv. What is happening? When the speed is increased, then wavelength decreases. So the wavelength is reduced. As wavelength reduced, then beta was equal to what? Lambda capital D by small d. So as lambda is decreasing, beta is decreasing, the fringes are coming closer. So the change will be the distance between the consecutive fringes will decrease. So answer to this is the third option. The question number 20 says that a ray of light is incident on a transparent glass sphere at 60 degree and is partially reflected and refracted at the farther surface of the sphere. The angle between the reflected and the refracted ray at the farther surface is, and mu for the glass is given √3. Now dear student, this was the sphere, and from here the ray is incident at angle of 60 degree. The refractive index of this glass is given equal to √3. So ray will go like this, and this is the angle of incidence. Now the center is at this point, and the ray will emerge out like this, and he says that partial will come into the same medium. So let's see what is this angle. Now if you take Snell's law, at the first refraction, then sine of 60 degree divided by sine of r will be equal to √3 by 1. So sine 60 means √3 by 2 divided by sine of r is equal to √3. So the sine r is half, or r is equal to 30 degree. So if this angle is 30 degrees, so this angle will be 30 degree from the sphere. So this angle is 30 degree. Now what is this angle? You can find again by the same rule. This is 30, so this angle become 60 degree. So emergent ray, this angle is 60 degree. And see, the ray which is reflected from here, this angle will also be 30 degree. Now this angle is required. Now look at this one. This total angle is 180 degree. So 180 degree is equal to angle 60 degree plus angle you require plus this angle which is 30 degree. So therefore the angle phi is equal to 90 degree. The angle between the refracted and the reflected fine rays. So answer to this question is 2.